When exploring the relationship between voltage, current, resistance, power, and energy, it's helpful to compare them to a water system in a firefighting setup. Imagine water flowing from a tower through pipes to spray on a fire. This mirrors electricity in a circuit. Voltage is like water pressure, determined by the water's quantity and height in a tower. Higher pressure means more force pushing the water. Similarly, voltage, known as electromotive force, is the push driving electrons through a circuit. The higher the voltage, the greater the force behind the electrons. Current is like the quantity of water that is flowing through the pipes. Electrically, it's the quantity of electrons flowing in the circuit at a given moment. Higher current means more electrons flowing, allowing the system to do more. Resistance is the opposition to flow, like narrower pipes slowing water. In electrical terms, resistance hinders electron movement. Larger conductors lower resistance, allowing more efficient electron flow, just as a wider pipe eases movement of water. Power is the actual work or the system's output, like force and volume of water spraying on the structure. Electrically, it is the useful work that is done, whether consuming power, like a light bulb, or producing power, like a solar panel. Higher power means greater immediate impact. Energy is power accumulated over time, the total volume of water sprayed to extinguish the fire. Higher power or longer time equals higher accumulation. Electrically, in watt hours, energy can be produced or consumed. By understanding these concepts through this firefighter analogy, you can see how voltage, current, resistance, power, and energy work together in electrical systems to efficiently harness and deliver clean energy.